Hello there. All right, let's start by sharing my screen. Okay, welcome everybody. Today we are going to work on Module 7, Lesson 7, Part 2. So this part will be inverse functions. We did a little bit on the HMH website, Task 2, to kind of have a look at it and see how it works. If you need me to make a video on that specific part, let me know. But here is what we did in class for note-taking and practice. So first thing off is that we went ahead and reviewed our fractions, right? So review of multiplying fractions. And of course, I put the date up as usual so that when you get your grade for your notebook that you have everything you need. All right, so review of multiplying fractions. We also reviewed this when we did Module 6, but I want to make sure that we do it again, as I saw a few people struggling on the quiz when they got to the reducing part. So if we have the fraction 3 over 4 times 2 over 5, there are a couple of ways we can do it. The first way is, or one way is to just multiply straight across the top. So 3 times 2 equals 6, and multiply straight across the bottom. 4 times 5 equals 20. Then, once you get there, you need to ask yourself, can we reduce? Because we want to get it into simplest form, right? And so when you're asking, can I reduce? You're just kind of thinking, like, could I divide both the top and the bottom by the same number? So can I divide by 2 over 2, or divide by 3 over 3, or divide by 5 over 5? Those are the three I usually check each time, because 2 over 2, if they're both even, then you can divide by 2 over 2. If you can divide by 3 over 3, that's not going to get caught when you're asking about 2's. I don't check for 4's unless 2 over 2 works, because 4 over 4, 6 over 6, 8 over 8, none of those are going to work unless 2 over 2 works. And then I check 5 over 5, right? Oh my. Okay, so we can divide by 2 over 2 because 6 and 20 are both even numbers, right? So I'm going to write it again. So we've got 6 over 20, and I'm going to reduce or simplify by 2 over 2. 6 divided by 2 equals 3, and 20 divided by 2 equals 10. Beautiful. And that's all you have to do. And so then the 3 over 10 is in reduced or simple form, and that's how we like it. Okay. I do want to talk a little bit about, why does this work, right? Why can we divide by 2 over 2? Like, just, it seems so random. Well, 2 over 2 equals 1. Keep in mind 4 over 4 equals 1. 8 over 8 equals 1, right? Because 2 divided by 2 is 1, 4 divided by 4 is 1, 8 divided by 8 is 1. So it doesn't matter. All of those numbers are 1. If you have the same thing in the numerator and the denominator, they equal 1. All right. So then let's think back to when we were little. 5 divided by 1 equals what? It equals 5. So notice that the 5 stays the same. All right. If we had 8 divided by 1, what would that equal? 8. Yeah, they're equal. Even if it was 28 divided by 1, we would still get 28. Like, dividing by 1 doesn't change how much stuff you have. So when you're probably in around 4th grade, we would usually teach you this by thinking about a cake, right? You have a big cake and we cut it into 20 pieces, and I eat 6 of those pieces. Don't judge. They were little pieces. We cut the cake into 20, right? So I ate 6 out of the 20 pieces. Or my friend had a cake the same size, but my friend only cut their cake into 10 pieces, and they ate 3 pieces. So who ate more cake? You have to think it through, because 6 pieces sounds like more cake, then only 3 pieces. But we actually ate the same amount of cake. I ate 6 little pieces of cake, and my friend ate 3 larger pieces of cake. But we had the same amount of cake because dividing by 1 doesn't change how much cake was eaten. All right. Let's also point out that we need to check here if we can reduce. So let's check here first. Can we reduce? So the answer is yes, we can reduce. So let's look at that again. If we have 3 over 4 times 2 over 5, we can reduce here. Now, by reduce, you're just thinking, can 3 go into 4 evenly? No, we would have a remainder, right? Can 3 go into 5 evenly? It cannot. If you're not sure what that means, like by evenly, I really like to use a times table chart for this. So in the 3's column, do I have any of the numbers that are on the bottom? So 3 is my column because it's on the top. Do I have a 4? No. Do I have a 5? No. So the 3 will not be able to reduce in this fraction. The ones on top cannot cancel each other out. So then I go look at the 2. I look at the 2. Do I have a 5? I do not have a 5. I look at the 2. Do I have a 4? Yes. So that means that I can reduce. Since I have a 2 and I have a 4 and they're in the same column, I can reduce. So let's go. 2 divided by 2 equals 1. And then we have to reduce this by 2 also. You have to reduce it by the same thing because it's just like we looked at here. It's got to be 2 over 2, like we did here, 2 over 2. So now basically I have 2 over 2. 4 divided by 2 equals 2. Now we can multiply across. So 3 times 1 equals 3, and 2 times 5 equals 10. When we do this quickly during our lessons, right, it actually just looks like this. I cross out the 2, I cross out the 4, and I write that we still have a 2 there. This is what we're doing when we're crossing out like that. Notice that I have a 1 left over there. I don't even write it down. And then we have 2 left over at the bottom. And so I write it there. So I would have had 2 times 5 is 10. I'm going to erase it at the top though, because that is not how we did that. We multiplied straight across up there. All right. And so then we have 3 over 10. And then check it out. Doesn't matter how you do it. 3 over 10, 3 over 10. The answer is the same. Now let's take a minute to practice dividing fractions. We have not done this at all this year. So we'll add this to our reminders from 4th and 5th grade. All right, divide fractions. Okay, so for example, if you had 5 over 2 divided by 1 over 6, what would that equal and how would we handle it? Now, a quick little reminder, we cannot reduce until it's multiplication. And I'm going to put that in a beautiful cloud to remind myself, right? So we cannot reduce until it's multiplication. All right, well, we're not in multiplication, Miss Efco, we're dividing. So what would we even do? So now lots of teachers will teach you different ways to remember this. So try to remember back to when you were in elementary school and use whatever tools they gave you. But basically your first fraction we keep. So 5 over 2, we're going to keep that or keep it the same. And then we're going to change our division to our multiplication problem, right? We're going to change that from division to multiplication. And you're like, oh, so what? We can just change it all willy-nilly, like it doesn't matter? You can only change it if you're then going to flip your second fraction. So now instead of 1/6, I'm going to have 6/1. So you're going to keep the first fraction the same. Change your sign from division to multiplication, and then flip your second fraction. I wish I had written that lower. All right, and now we can just multiply straight across. 5 times 6 is 30. 2 times 1 is 2. Here, you can either know that 30 divided by 2 is 15, or we can reduce it by using 2/2. 30 divided by 2 is 15. 2 divided by 2 is 1. And then when we have a fraction over 1, we typically write it as just a regular kindergarten number. So our answer is 15. However, let's go ahead and check, can we reduce here? Right? If you don't want to wait till the end to reduce, could we have reduced here? And the answer is absolutely we could have. So let's rewrite that problem. If we have 5/2 times, we have multiplication now, so that means we can reduce, right? Times 6/1. But we want to see if we can reduce first. So can we reduce by a 2/2, 3/3, 5/5? Those are what we check for. So we can reduce by a 2 here and with the 6. So we're going to divide by 2, that equals 1. We're going to divide by 2, that equals 3. Notice again, whatever you divided by on the bottom, you have to divide by on the top, okay? And this only works in multiplication. So now we have 5 times 3 equals 15, and 1 times 1 equals 1. And again, when we have a fraction over 1, we usually write it like that, like a kindergarten number. All right, pause here if you need to copy more. I'm turning the page. All right. Module 7, Lesson 1, Part 2, Inverse Functions. So our same title. Still the 20th. All right. So we're going to kind of set up our paper a little differently. Here we're going to have the problem. And then I think about here, I'm going to write our steps. And then there's a couple of little side things I mentioned. So we're going to write side notes over here, and I'll try to keep it clear what we're doing there. Okay. So now we're actually going to talk about how to find the inverse of a function. All right. So our problem is j of x equals 3/5 x plus 10. So that is our problem, and we need to find the inverse. So I'm going to say that our first step is to solve for x. Now, when I looked on Khan Academy to research a little bit different ways to teach this, they start the problem by switching their x and their y. And then later, when they get to more complicated problems, they do it at the end. And then our book switches at the end right from the beginning. So we're going to switch. I'll show you what I mean. We're going to switch our x and our y at the end. But just know that if you go to Khan Academy for help, they do it a little bit earlier than that. So I need to solve for x. So let's start by making it look a little simpler by calling our function y. And then solving for x means I want to get x alone. Well, x is not alone at the moment. It has a 3/5 with it and a plus 10. So I'm going to use PEMDAS, right, our order of operations, in reverse order to get rid of things. So in PEMDAS, adding and subtracting is usually the last thing we do. So here it's going to be the first thing we do because we're moving stuff away from the x. So I'm going to go minus 10 to both sides. Now this is beautiful because it cancels. Positive 10, negative 10, that's 0. So on this side, I'll get 3/5 x. And then here, this messes with my brain a little bit to have the y and the -10 like in line above each other because they are not like terms. So there's nothing I can do with them. So I'll just write them separately. The y first, following our rules for highest exponents. So y -10 equals 3/5x. Now, a beautiful thing we could do, and I'm going to do this twice, but a beautiful thing we could do is to multiply times 5/3, okay? And the reason that this would be beautiful is because the 5s would cancel and the 3s would cancel, and we would be left with x, just one x, because 3 divided by 3 is 1, 5 divided by 5 is 1, right? We get 1. It's gorgeous. And then that would mean that I would just have to multiply this side times 5/3, and then we could have 5/3 times y -10. Okay? And this would actually be a beautiful way to leave this, but that is not how I did it in class, so I'm going to do it the way I did it in class. So here's one of those side notes. So let's take it from here. Side note is that 3/5x is exactly the same as 3x/5. Just two ways to write it. They are both, it's both equal. You're either, like here, you're multiplying 3 times x and then dividing it all by 5. Or here, you're dividing 3 by 5 and then multiplying that times x. Both work. So let's do it that way over here. Let me find a good color to box it off with. All right, so I'm going to do this same step just over here on the other side. So we could also have y -10 equals 3x/5, right? And here it might be a little bit easier to see that since 3x is being divided by 5, I need to multiply times 5 so that those two will cancel, and then I'll be left with 3x. And then what you do to one side, you have to do the other. So I'm going to have this y -10 times 5. So I'm going to go 5 times y -10. Now, to get my x alone, the next thing I'm going to do is divide by 3. But in every single class today, everybody wanted to multiply the 5 into here first. And we can absolutely do that, but it's not going to help us get the x alone. So I will do it though, because that's where your brain goes, what you want to do. So we'll distribute this. 5y -50 equals 3x. And now we're going to divide by 3, and we're going to divide this whole thing by 3. So we end up with 5y -50 over 3 equals x. And now we are to our second step. So notice all of this was solved for x. Solving for x takes a few steps, right? Step 2 is to invert or trade your variables. I'm going to write trade x and y. Okay? And I use the word invert instead of just trade or change or swap or switch because this is called inverse functions. So I want to have that word inverse or invert in there. So I am literally going to write the problem again, but where I have my y, I'm going to make it an x. So now it's going to be 5x -50 over 3 equals, I'm going to change my x to a y. Okay. And then I'm going to go ahead and put that in a box because I'm going to need it later. I would also like to point out that this is the inverse of the function j of x. So in the beginning of our problem, it is called j of x, right? And then at the end of our problem, it is called j inverse of x, right? And these are opposites, okay? They're like a reflection of each other. Now, from here, our next direction is to verify or justify or check, right? What your answer is using composition. And composition is what we learned last week, right? So we're going to take these two equations, and those will be what we write down, and then we'll plug them into each other, okay? I use all three words, verify, justify, or check, because I've seen all three on either state tests, testings, the directions for state testing, like different places. So I don't want you to get messed up just on the word. It means to check it to see if you're right. Okay. All right. So let's start by dividing our paper in half, just like we did all last week. Our first equation is j of x equals 3 over 5x plus 10. And then our other equation is j inverse, so j to the negative 1 of x equals, and that's where we write what we have in the box, 5x minus 50 all over 3 equals y. No, I don't need the equals y, so sorry, because we've got the j inverse right there. All right. And then we could predict that they're both going to be lines. To be a parabola, you have to have an x squared. That would give us a parabola shape, right? But without a squared, there's no way to get the parabola. So I've written the equation. I've written my prediction for the line. I need to draw an x, right? I need to know what composition I'm doing. So what I'm doing is just going through these 14 steps that we wrote down last week, right? I wrote down the f of x and the g of x, which in this case is a j and a j negative 1. Predicted the shape of the graph. Now I'm going to write the order of them, and then I'm going to write the first, like I'm just going through these steps again to do the composition. All right, so we're going to do the j composed with the j inverse of x. And then we're going to do the j inverse composed with j of x. All right. Okay, so starting here we go. So first thing, I write down the equation. So I change it to a y to make it easier. Y equals 3 over 5x plus 10. And then I draw a line to my x to show that I'm going to plug in the 5x minus 50 all over 3. Okay. Now, just like we pointed out in our side notes, 3 over 5x or 3x over 5, it both equals the same thing. So I'm going to write this in pencil so that you can see the difference, and then we'll choose which one we want to use. So that means I can either write 3 over 5 times 5x minus 50 over 3. Like I can multiply them like that with it outside. And then I'd still have the plus 10. Or I can do 3 times 5x minus 50 over 3 plus 10 all over 5. Having a fraction on top of a fraction gets more complicated. We're going to learn how to do it anyhow, but I would like to avoid that for the moment. This one looks like I could just multiply straight across or maybe even reduce. All right, so I'm going to erase the second one and we will use this one. So super handy if you just notice that we have a 3 in the numerator and a 3 in the denominator so that I can cancel those out. 3 divided by 3, like I'll write it down, we're dividing by 3 equals 1. 3 divided by 3 equals 1. And now I can multiply across. 1 times all of that will still be 5x minus 50 over, and then 5 times 1 is 5. And then don't forget we have a plus 10 out there. Thank you for yelling at me to move it. I appreciate you. Now, I notice that there's a bunch of 5s here that I could play with, but there are rules, right? So I'll show you both ways to do it. I didn't show both ways in class, but I'll show it here. So one way is to just rewrite it so that we have 5x over 5 minus 50 over 5. I can just pull these terms apart as long as I keep the denominator under each half. And then this is beautiful because 5 goes into 5 one time. I get x minus 50 divided by 5. Or you can think about it like this. 5 divided by 5 equals 1. 50 divided by 5 equals 10. So that's going to be minus 10. And then plus this 10. I'll write it in both places so we don't lose it. X minus 10 plus 10. Well, minus 10 plus 10 is 0. So we get y equals x. Because remember out here, we've had a y the whole time, right? Y equals x is actually correct for this answer. It means that when we plugged it in, we got the inverse. So if we plug in the domain, we get the range. If we plug in the range, we get the domain. Beautiful. So the other way to have done it would be back in this step, right? We could have done, hey, can I take something out? And sure enough, we can take a 5 out of there, right? So we could have gone, take out a 5. That leaves us with x, because 5 divided by 5 is 1x, minus, and then 50 divided by 5 is going to be 10. All over 5, and then don't forget our plus 10. Then the 5 just beautifully cancels. And this would continue on to give us x minus 10 plus 10, which is y equals x. And so again, still a smiley face, right? Just 2 ways to do it. Maybe I should box that off. There you go. Okay, and then we're going to come over here and do it again. So on this one, we start by, we wrote the equation, we wrote the line, we wrote how to do it. I'm going to write the equation with a y so that it's easier. So we get y equals 5x minus 50 over 3. Next step, we're going to draw a line, an arrow to our x, and we're going to write down what we have to plug in, which is 3/5 x plus 10. I like to put that into parentheses so that I make sure I insert it for the x. So then that's going to give us 5 times. Notice I don't put the x out here anymore because this x is disappearing. It's becoming all of this instead. So then we have 3 over 5x plus 10 minus 50 all over 3. So just to be clear, this 5 becomes this 5. The x becomes everything that we wrote here, 3/5 x plus 10, all inside parentheses. Minus 50 was this minus 50 up here, and then we still had everything over 3. Okay? So I would like to deal with the whole top part first. I would like to ignore that 3 on the bottom for a little while. So I'm going to do any math I can at the top, and then we'll deal with the 3 next. Okay? So yeah, I think we should distribute, right? Let's distribute this 5 times the 3/5 x and times the 10. I'm going to write it out so we know exactly what we did. So that would be 5 And I'm going to turn my 5 into a fraction so that I can see it better next to my 3/5. So 5 over 1 times 3 over 5x plus, and then 5 times 10. I should have just written it bigger, sorry. 5 times 10. So this 5 times 3/5 x, and this 5 times 10. And then minus 50 all over 3. So looking at just this part, do you see anything that we can reduce? Is there anything that we can reduce in that section? Yeah, hopefully you see that we have a 5 on the top and a 5 on the bottom. So those would each turn into 1s. And so we get 5 divided by 5 equals 1, 5 divided by 5 equals 1. And so 1 times 3 is 3. 1 times 1 is 1. We don't need it on the bottom anymore. So we end up with 3x plus 50 minus 50. Well, what's 50 minus 50? That's 0. Okay, so then I just have 3x. So I'm going to go 3x over 3. 3 divided by 3 is 1. So we end up with just x. And then way back at the beginning, we had a y equals. So this is also correct. Nice job. Look at you go. Pause if you need to catch up. All right, on we go. This is our last page, if that helps you to plan better. All right, so we've got Module 7, Lesson 1, Part 2, Inverse. Right? And today is the 20th of January, 2026. All right, so we're going to start with the problem, which is g of x equals 6x minus 1/2. In class, you did this in groups around the room. So if you're doing this at home, I strongly, strongly encourage you to pause and go try it without me and then come back. And don't try the whole thing with the checking. Just see if you can get the inverse. Come and see if you got it right. And then we'll go on after that. All right. So step 1 is to solve, get x by itself, right? Solve for x. So I'm going to go plus 1/2, plus 1/2, changing this to a y. Y plus 1/2 equals 6x. Then we're going to divide by 6, divide both sides by 6, right? Well, this is beautiful because it cancels, so I get just an x on one side. But here, we are not allowed to have a fraction in a fraction. So I have to find a way to simplify this. So what I'm going to do is I'm going to break it apart. I'm going to go y over 6 because that's allowed. So I can leave that. Plus 1/2 over 6. And that's where you're like, whoa, 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 Miss Hetko, you just said we can't have a fraction in a fraction. You're correct. So then this is where I like to take a little colored pencil. And then let's just come over here to do a little work with fractions. And then we'll come back to that. All right. So this is saying 1/2 divided by 6. Now I'd like to make this into a fraction so that I can use my dividing by fractions review that we just did. So in my dividing by fractions review, I know that I keep, right, the first fraction. I change the division to multiplication, and then I flip the 6 over 1 to be 1 over 6. Check and see if you can reduce. We cannot reduce. We've only got 1s on the top. They don't reduce. So then I just multiply across. 1 times 1 is 1. 2 times 6 is 12. And then I'm going to rewrite my problem. So now I've got y over 6 plus 1 over 12 equals x. Step 2, before I can call it an inverse, is I have to invert, right, the x and the y. So let's make sure we're writing that. Step 2, invert x and y. So now I'm going to have x over 6 plus 1 over 12 equals y. That can now go in a box. And then I would like to also label that g inverse of x. Calling it the g to the negative 1, right? Calling it the g inverse is going to help us in our composition step. If you made it to this step, right? That's awesome. Like you did all of the steps we needed to do to get the x by itself. You just didn't know the rule about not having a fraction in a fraction. So you're doing great. But this is one that you're going to have to remember. Okay. So then I'm dividing my paper in half like this, because this is where we're checking it, right? So for checking it, over here, I'm going to do the g composed of the g inverse. And then on the right, I will do the g inverse composed with g. And I divided my paper down the center so that it looks like we set it up, how we set it up last week, right? Just try to get our brains to think about it again. All right. So I'm going to write down my equation, which is g of x. It's way up here at the beginning. I can't even see it on the screen anymore, but that is g of x minus 1/2. I can predict again that this is going to be a line. The predicting is not as important as it was last week, but still a good habit to get into. All right. And now I'm going to draw a line, an arrow, sorry, showing that I'm putting in the other equation. So let me come over here and write our other equation. G inverse of x is what we had in our box. So that's going to be x over 6 plus 1 over 12. And so that's what I have to plug in over here. So I'm going to write in parentheses x over 6 plus 1 over 12. And then here we go. Instead of g of x, I'm going to write y equals 6 times x over 6 plus 1 over 12 minus 1/2. And now we have to do all the math for that. So where do you think we'll start? If you're thinking you want to add half to both sides, we would not do that because we're not trying to get the x by itself. We want to know what y equals. So we actually just want to solve all of this side, do as much work as we can there. Okay. So we can make this coefficient a 6 over 1 and multiply it times everything inside, right? So that's going to give us y equals 6 over 1 times x over 6 plus 6 over 1 times 1 over 12 minus 1/2. Now, looking at just this part, right, just the multiplication part, is there anything that we can reduce? Yeah, we can reduce the 6 on the top and the 6 on the bottom. And that's going to leave us with just a beautiful x. So pretty. Plus, here we can also reduce. I can go 6 divided by 6 equals 1, and 12 divided by 6 equals 2. And then 1 times 1 is 1. And then on the bottom, the denominator, 1 times 2 is 2. And then we still have this minus 1/2. If you didn't see this reducing, it would still work out because you would multiply straight across and you would get 6 over 12. And that would give you, you could divide by 6 over 6. If you don't see that it's 6 over 6 and you only did 2, that would be fine. You would just then have to see that you could divide by 3 over 3. So we're doing it one step. 6 divided by 6 is 1, 12 divided by 6 is 2. And that's where you get that 1/2. Then, super fun, plus 1/2 minus 1/2 is 0. So we get x plus 0. Well, we don't need that. And then there used to be a y over here. If we get y equals x, we're doing it right. That means our inverting was done correctly and it works. The reason it's important to check is that we're going to eventually be doing it with numbers, like the x is going to be a 4, and then you have to find out if 4 works. And if you get like 3 equals 3, then yes, 4 works. But if you get 3 equals -2, then 4 does not work. It is not an actual solution. Okay. This would be a really good place to stop and see if you could do this side by yourself. Welcome back. All right, so we have all of this. I'm going to draw my arrow. I think this is a line. Drawing my arrow, and I'm going to plug in 6x minus 1/2. All right, so that has to go in for the x. So that means I have 6x minus 1/2 all over 6. Oh, I see I'm going to have a problem there with a fraction over a fraction. Plus 1 over 12. So I think I'm going to separate this again like I did up above, right? To be able to divide this 1/2 by 6. So that means I'm going to have 6x over 6 minus 1/2 over 6 plus 1/12. I'm going to use my colored pen to go do this work over here. So I get 1/2 divided by 6. I'm going to keep the 1/2. I'm going to change the division to a multiplication. And I'm going to flip the 6. Well, how can I flip the 6? It's not even a fraction. Well, 6 is a fraction. We just don't write the over 1 all the time. So to flip it, we're going to get 1 over 6. There's nothing I can reduce because I only have 1s as numerators. And so I'll do 1 times 1 is 1. 2 times 6 is 12. And then I'm going to rewrite it, plugging it in for where that one was, because that's the work I just did off to the side, right? So then we get 6x over 6 minus 1 over 12 plus 1 over 12. Well, this is beautiful because minus 1/12 plus 1/12, that's 0. That's going to be plus 0. And here we have 6 over 6. When you have the same number in the numerator and the denominator, it's 1. So we have 1x plus 0. So we have y equals x. And that's what we're going for. Right on. Okay, that's everything we did today. Have a good one. I will see you soon.